All right, so I want to make a quick video on this concept here. And this is on his first video, really the last example that he showed. And what he's asking us is what is going to form, what alkene is going to form this product? Okay, and just looking at this, we're obviously going to look at the bromine. Okay, we know that the double bond, that bridge of the double bond, spawns off of this. So our options are this, or this, or this. Okay, those are our three options. And first I did think that this would be the first option. But when you think about both sides of the bridge, you're then putting a tertiary carbon versus a tertiary carbon. And we don't want that, because that is going to lead to a 50-50 mix of results, whether the BR is here, which is where we want it, or whether the BR is here, where we don't want it. So that's not a good location for this. So now we can think about the other two locations, because we want to always form this result, okay? That is a good starting material. And this is an example of what I just drew. So this is tertiary versus tertiary. So this is not good. Tertiary is really like, where are you placing the positive charge? Ultimately, that's where this electronegative bromine is going to sit, okay? And the hydrogen will go on the other side. What would be a better option, and really if you put the double bond here, or if you put it here, it's really the same thing. If you were to flip this compound over, it's completely symmetrical, so that would still work. But this is a better option, because when you're looking at this as your bridge, you're pitting this carbon versus this carbon. And this carbon is attached to three others. It is tertiary. But this one, on the other side of the bridge, is only attached to one carbon, making it primary. And remember, a primary carbon is not stable. It forms slower, or not at all, or it's very difficult to form. Something that is more stable, a tertiary, is going to form faster, it's going to be more stable, and it's going to be your major product, which is really what we're concerned here in this class, okay? And this, a tertiary versus a primary, is what we call regioselective, and I think this is either highly or completely regioselective, because this tertiary stable is going to be favored, and that is going to result to, and to just complete this here, we get rid of the double bond. We pit hydrogen versus positive charge. We want to put hydrogen on the carbon that has more hydrogens already attached to it. Remember this one, which had a double bond, is a CH2. So we're going to throw this hydrogen on here. And we want to put our positive charge on the more stable carbon, which will be here, which will then eventually be replaced with a bromine, which gives us, it's drawn a little bit differently, but which gives us our result here.